Okay, this video is going to give you some basic information about hydrocarbons. So when I say that term, hydrocarbon, I'm talking about a substance that contains only carbon and hydrogen. Now if we assume that the simplest form of hydrocarbon would be methane, it makes sense that you have one carbon and four hydrogens. It gets more complicated when you start adding carbons to the chain. So the simplest hydrocarbon is CH4 and it's called methane. 2 carbons is called ethane, C2H6. 3 carbons is called propane, C3H8. And 4 carbons is called butane, C4H10. What do these all have in common besides the fact that they are hydrocarbons? They have all single bonds, their name ends with ANE, and the formula for the number of carbons and hydrogens follows the following pattern. CnH2n plus 2. Now this hydrocarbon is called an alkane when it contains all single bonds. So we talked about methane, ethane, propane, and butane. After you get to 5 carbons, once you get to 5 carbons, the names will sound like you are in geometry class. We use the prefixes that come from the Greek. So pentane, C5H12. Again, notice the pattern, 2n plus 2 for the number of hydrogens. 6 carbons is called hexane, C6H14. 7 carbons is called heptane, C7H16. And of course, 8 carbons would be octane, C8H18. And you can go on from there. Nonane, decane, things like that. Now, if your hydrocarbon contains a ring, well then the formula is a little bit different. Instead of 2n plus 2, it's just CnH2n. And the reason why you lose those 2 hydrogens is because when the chain closes on itself, those 2 hydrogens on the end will go away. So the formula for a 3-membered ring is not C3H8, but C3H6. And the name propane is still there, but we call it cyclopropane. So the prefix cyclo is added when you have a ring. Of course, 4 carbons is butane, but this is cyclobutane, C4H8. 5 carbons in a ring is called cyclopentane, C5H10. And you could have cyclohexane, cycloheptane, cyclooctane, etc. Another way to change the structure of a hydrocarbon is to have a double bond. So we talked about alkanes where the ending was ane. Now these would be called alkenes where the ending is ene. So there is no such thing as methane because you have to have at least 2 carbons to make a double bond, but there is ethene. It's also known as ethylene and the formula is C2H4. When you have 3 carbons and a double bond, it's called propene, also known as propylene, C3H6. Now after that would be 4 carbons. Remember that the name would be bute, but not butane, butene. Now here we have a little bit of an issue with where the double bond is located. In these 2 examples, you can see that the double bond is either on the end or the double bond is in the middle. Now if there's any confusion about the location of the double bond, it is numbered. The carbon chain is numbered in order, and the number refers to the lowest number of carbon atoms. So when the double bond is on the end, we call it 1-butene. When the double bond is in the middle, we call it 2-butene. And you might be wondering, is there a separate molecule known as 3-butene? Well, hopefully you can see why there is no such thing as 3-butene. We always use the lowest number possible. So by flipping this molecule around, it would become 1-butene. So the molecule 3-butene does not exist. Now to check for understanding. Let's start with a formula, a structural formula for C4H8. This is the molecular formula, C4H8. Well, if we begin with double bonds, we already know that you could have the double bond on the end, So 1-butene and 2-butene are two examples. And we know there's no such thing as 3-butene. So you might wonder, what else is there? Oh, and by the way, this particular molecule, 2-butene, actually has two different isomers that are called cis and trans. And those are geometric isomers, but I'm not going to teach that right now in this tutorial. Well, instead of having 4 carbons in a row, you could have 3 carbons in a row with a double bond, and this would be the molecule that you come up with. It's called propene when we have 3 carbons in a row and we have a double bond. Now I have to put a branch on the carbon chain, and this particular branch, CH3, is known as a methyl group. Now hopefully you can understand why we're not allowed to put the methyl group on the end, because that would extend the length of the carbon chain from 3 to 4. If the methyl group were located here, that would be called butene. So the only place I can put a methyl group on propene and not extend the carbon chain would be to put it on carbon number 2. So 2-methylpropene is a unique molecule that we haven't seen so far. Well, that's pretty much it for examples of carbons that contain the carbon chain with a double bond. Don't forget, we can also have cycloalkanes. So what are different cycloalkanes you could have for C4H8? Well, there's the most obvious, cyclobutane. But you could also have a 3-carbon ring with a methyl group on the side. And the name of that molecule would be called methyl cyclopropane. And now that's it. All of those are the only examples you could think of for drawing C4H8. Alright, let's take a look at another example, C5H10. And we'll start with double bonds. You could have 5 carbons in a row with the double bond on the end, and the name is 1-pentene. If you put the double bond on carbon 2, that would be called 2-pentene. Now, is there such thing as 3-pentene? Hopefully you can see no. That would not exist because you'd simply number the carbon chain from the other side. So there is no such thing as 3-pentene. Well, in general, we've already put 5 carbons in a row. Let's try 4 carbons in a row. This would be called butene. And because the double bond is on the end, this would be called 1-butene. And our methyl group would be on either carbon 2 or carbon 3. And these are unique molecules that have different names. So 2-methyl, 1-butene. And then now with the methyl group attached to carbon 3, 3-methyl, 1-butene. Is there any other type of butene molecule? Yes. There's 2-butene, and we're going to put the methyl group on carbon 2, and that's the only other possibility of having double bonds. Now on to cycloalkanes. There's cyclopentane with 5 carbons connected in a ring. If instead of 5 carbons you have 4 carbons in a ring, you could have 1 methyl group, and the name of that would be methyl cyclobutane. Instead of 4 carbons in a ring, you could have a 3-carbon ring, which is called cyclopropane. But now you have to have either 2 methyl groups or possibly an ethyl group. Let's take a look at the 2 methyl groups. If the 2 methyl groups are on the same carbon, we call it 1,1-dimethyl cyclopropane. If the 2 methyl groups are on adjacent carbons, we call it 1,2-dimethyl cyclopropane. And then finally, you could have a cyclopropane with a 2-carbon branch coming off of it, and that is known as an ethyl group. So the last example would be ethyl cyclopropane. Well, this is not an exhaustive list of all the different types of organic compounds that are out there. This just gets you started thinking about how to draw structural formulas for simple hydrocarbons. If you have any further questions, please see me.